Take a look at this website. It is meant to provide a unique holiday experience to all types of customers. But is it really inclusive for everyone? Using a generic accessibility check, this website gets a perfect score. So it seems that the travel team has done a really good job. However, this is completely inaccessible to anyone using assistive technology like a screen reader, keyboard or pointing devices. As a person who can see, you can, within a fraction of a second, understand the main purpose of the site, in this case, to search for and book a vacation. You knew that because you recognized a drop-down and a date picker with its calendar icon visually, since they follow common UX and UI paradigms. Now imagine that a screen reader needs to communicate that to a blind user. The screen reader needs to know that the element is a drop-down that allows the user to select their new vacation home. In this case, the drop-down was implemented the wrong way. It looks the same, but it's inaccessible to screen readers. All existing accessibility tools would look at this code and not know that it's an accessibility problem because they do not have the context that this element is actually a drop-down. Evinced does not rely only on the code to understand the meaning of elements on the page. We start by visually analyzing the UX and the UI as a sighted person would. Using sophisticated computer vision and machine learning algorithms, we identify and classify all the interactable elements on the page, like drop-downs, date pickers, input fields and radio buttons, and only then look at the code underneath to understand if it conveys the functionality correctly to a screen reader. This unique approach of UI/UX down as opposed to code up is what enables Evince to not only detect all accessibility issues, but also auto-generate suggestions to fix or remediate the code. Doing the right thing just became a lot easier.